Following two annuities immediate have the same present value at annual effective rate I. Number one, a 10-year annuity with annual payments 475. Number two, a perpetuity with annual payments of 400 in years 1 through 5, 0 in years 6 through 10, and 400 in years 11 and beyond. Calculate I. So both these streams have the same present value. Let the common present value be denoted by X. Let's first concentrate on the first one. That's a 10-year annuity immediate. Both of them are immediates, as mentioned in the first line. First one's a 10-year annuity immediate with payments of 475. So if we call its present value as X, then X by the basic 25.4 formula will be X is equal to 475. That's the payment times 1 minus 1 plus I to the negative N. N is the number of payments, which in this case is 10. This is 10-year annuity divided by I. And now the second stream is a bit more complicated, because first part of it, so they say it's a perpetuity, but the first part of it, with the payments 1 through 5, that's just an annuity immediate. Now, if we didn't have this zero payment portion in year 6 through 10, then the whole thing was very simple. It was the present value would just be 400 over I. But because of these in between zero payments, we have to break it up into this first 5 payments, which is an annuity immediate with 5 payments. And then the second part is the perpetuity. We can ignore the zero payments in the in-between years. So the perpetuity part or the infinite part starts from year 11 and beyond. So first 5 payments, annuity immediate, 400 is the payment. So the present value of these first 5 payments would again by 25.4 be 400 times 1 minus 1 plus I to the negative 5 over I. And now the second stream, the payments start at, in the second stream, the infinite part of the payments start at time 11. And if we apply the perpetuity immediate formula, the value of these will be obtained at time 10, because remember that any kind of annuity immediate or perpetuity immediate gives the present value 1 period before the first payment. So if the first payment is happening at time 11, and if we apply the perpetuity formula here, then the value given by that formula will be at time 10. So the value of payments 11 onwards of the stream 2 at time 10 will be 400 over I. Remember, it's just X over I for a perpetuity immediate. And now we need to bring this back from time 10 to time 0. So we multiply it with a factor of 1 plus I to the negative 10. And therefore, the total present value of stream 2 will be the present value of these first 5 payments plus the present value of the infinite part, which is 400 over I times 1 plus I to the negative 10. And this is also equal to X because we're told that the first and second stream both have the same present value. So now from 1 and 4, we get 475, 1 minus 1 plus I to the negative 10 over I equals all this right-hand side of 4. And the i's can cancel out. And now we can let 1 plus I to the negative 5 as y. So the 1 plus I to the negative 10 will be y squared. So then after canceling out the i's in all the 3 terms, we have 475, 1 minus y squared equals 400, 1 minus y plus 400 y squared. And we can collect. So this is, when you open this up, this is 475 minus 475 y squared. So the negative 475 y squared can go to the other side and become a positive 475 y squared. Added to the 400, it gives us 875 y squared. And then 400 negative 400 y is already, so we are basically collecting everything on the right hand side. So this is negative 400 y, and then this is 400, and then the 475 comes on the right side and gets subtracted. So 400 minus 475 is negative 75. So now this is the quadratic equation. So when we apply the quadratic formula, the positive root is 0.6. The other value is negative, and that cannot be because y is an exponential function which can never be negative. So we have 1 plus I to the negative 5 is 0.6, and we take the negative 1/5 root of both sides. So we evaluate negative, we evaluate 0.6 to the negative 1/5, and then subtract 1, so I comes out to be 0.1076, which is 10.76%, which is choice B.